Hey, how you doing? My name's Elton and welcome to the Container Show. So this month we're all talking about orchestration. That's the theme for the month. If you saw the previous episode, that was ECS-O1. We looked at an introduction to what an orchestrator really is and kind of unpicked that terminology around orchestration and clusters and nodes and saw what an orchestrator gives you. And for the rest of this month, we're going to look at specific orchestrators. So today, we're ECS-O2. We're looking at Docker Swarm. So Docker Swarm is pretty much the easiest orchestrator to get up and running with because everything you need for Swarm is built right into the Docker engine. So whether you're running Docker Desktop on your developer machine or whether you're running Docker on your servers in your data center, you can spin up a cluster just by running a few Docker commands, join a whole bunch of new servers in, and then run your containers at scale in a production-like environment. And that's exactly what we're going to see today. So last week we had a few slides. That's going to be the exception, I expect, because mostly this show is all about demos. So I'm going to switch right over now and show you some demos. We're going to spin up a cluster by running some Docker Swarm commands. We're going to see how to deploy the really basic, annoying to-do application just using the Docker Compose syntax. That's what's so great about Docker Swarm. You don't really need anything additional to spin up your cluster. And when you start modeling your applications, you're going to be using the Docker Compose syntax, which you're already familiar with because the learning path tends to be Docker run commands, then Docker Compose, and then move on to an orchestrator. And even if you're planning to use Kubernetes when you get to production, the learning path for Kubernetes is pretty steep. It doesn't use the Compose format. Has its own specification for modeling your applications. So understanding how Docker Swarm works is a really good stepping stone. So stick with me for this episode. I'm going to learn about Docker Swarm. I'm going to switch over to this camera now. So to do that, I've got to pull down my green screen. So if you're a regular viewer, you know what happens now. If you're a new viewer, then hi. I'm going to switch to a short advert while I pull down my green screen and sort myself out. And I'll see you in about 20 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. While I'm fiddling with my green screen, you might want to bookmark this page, eltons.show, which is where you'll find all the details of all the episodes. I go into quite a lot of depth in these shows, so if you want a primer around these technologies, I can recommend my books, Learn Docker in a Month of Lunches, and Learn Kubernetes in a Month of Lunches. And if you just want to see what I'm up to, then you can check out my blog, blog.sixside.com. And now, back to the show. Okay, and here we are. So the format of the show is everything's pretty much demo based. You'll see all of the information up on GitHub. So if you go to the eltons.show link, that will take you to the GitHub repo where everything that I'm going to show you is written down there. So I'm going to go through all these markdown files where I have each episode, all the steps I'm going to take, and you can follow along with yourself. There's usually a prerequisite section to tell you what you need to install if you want to try these things yourself. And mostly it's just about showing you how these things kind of work. So there's a whole bunch of kind of verbiage in between the demos, but I won't read all that out. That's for if you want to follow this on yourself later on to give you some hints and reminders about what I was actually doing. So I've spun up a whole bunch of vagrant virtual machines for this. So because we're going to be running a genuine cluster with multiple machines, I've got multiple virtual machines that I'm going to connect together. Now, you can do this yourself just with Docker Desktop, but you only have one machine. So you can switch to Swarm mode, which is what Docker calls Docker Swarm, the orchestrator, when you're running on Docker Desktop, but you've only got one machine, so you won't be able to kind of scale up across multiple servers, but the commands work in the same way. It's the same syntax. So if you want to try it out and you're just using desktop, then you can get started with that too. Okay, so let me close down my browser here and open up my terminal. And the first thing I'm going to do is I've already got my connections to my vagrant machine. So I've got 3 machines running. I've got a machine called the manager, and then I've got 2 machines called worker 1 and worker 2. So Docker Swarm has a structure of having managers who do the actual orchestration. So when you make requests, you talk to the manager, and the manager controls the cluster. And so it distributes work among the worker nodes, and they run your actual containers. But with Docker Swarm, you can also run your user workloads, your user containers on the manager nodes, and you kind of decide where you want to run those things. So we won't get into that level of detail, but just be aware that there is this kind of split between the managers that run the orchestration components and the workers that just run your own containers. Okay, so I'm connected to this manager node, but there's nothing special about them. They just all have Docker installed. So all I've done with all these machines here is I've got Docker up and running, and that's all in the vagrant scripts that are in that GitHub repo. So you can see how it's all set up. It's really super simple. You don't need a particular version of Docker because Swarm has been around for 5 years now. So as long as you're using a relatively recent version of Docker, you'll have all that stuff. And that's all you need. Not like some of the other orchestrators where you install multiple components and the bits of the orchestration engine run across several different components themselves. With Docker, everything runs in the Docker engine. So let's clear this down. Remember that I'm in Linux and I can't use CLS. And the way you create your cluster is you choose a node that's going to be your manager, and then you run this docker swarm init command. And all that does is it initializes the swarm. So it switches to swarm mode, and it gives you this huge output here, which is this docker swarm join token. And you're going to use that on the other nodes to connect to your manager node. So the idea of the swarm is that that you initialize your managers, and then you join in as many worker nodes as you want. But the swarm token is the kind of security mechanism. So it's kind of like a password, and then when you join the swarm, that your node creates a certificate, so that the swarm manages encrypted communication between all the machines in the cluster, so that every machine has its own TLS certificate. It's mutual TLS, so everything's encrypted. The machine you're connecting to can verify it's you, and you can verify it's the machine you're connecting to. And that swarm token is the thing you need to join into the swarm. So I'm going to take a copy of that and put it in my in a text editor here, so that I can use that later. So let's just make sure I've got that, because you need that to join in with your swarm. If you lose that join token, that's fine, because you can always get it again. When you're connected to the manager, you can run the docker swarm join token command. And there are two different tokens depending on whether you want to join your new node as another manager, which you will do if you want a highly available production environment. You'll typically have three managers, and three managers, they distribute all the orchestration components between them. And if one of them goes down, another one can take over. But if you want to join a worker node, you run docker swarm join token with the worker parameter, and you see that join token again. So the format of this token is kind of deliberate. It always starts with swarm token, so that if you can set up your GitHub repo or wherever you're storing your source code to check to see if somebody accidentally checks one of those things in and commits it to your source code repo. So then you can rotate your tokens, and then this is effectively, if someone's got access to your network and they've got your swarm token, then they can join a rogue node to your cluster. So so that's all set up on my manager. So my manager is ready to go now. You can have a swarm with a single node. So if I do a docker node ls, this shows me all my nodes. I've just got one, which is my manager node, but I'm going to join my other two VMs to this same cluster. So let's make sure I've got this token saved. And I'll switch over to a different one of my nodes now. So these are all running in, I'm using Windows 10, so these are running as Hyper-V machines. And again, they've got installed is Docker. So I'm going to, and they always the same setup script. So there's nothing special about the manager or the worker nodes. So on my worker node, I'll run that docker swarm join command. You'll run the same command yourself, but what will be different is you'll obviously have a different token, because that's generated for each cluster. And the IP address is the IP address of the master that you're going to connect to. If you're in a real environment, a data center environment, you're also going to need to open some ports. And on the Docker Swarm documentation, it tells you which ports you need for the servers to communicate with each other. Okay, so then you get this output that says this node joins swarm as a worker. So I've now got two nodes in my swarm. If I go to my other machine, my worker 2 machine, paste that same docker join command, and this joins as a worker 2. So now I've got 3 nodes, and that's literally it. So if you've ever set up a Kubernetes cluster, then there's a lot more to it. And if you haven't done that, then join me next week, because we will do that next week. This is it for Docker Swarm. You just install Docker, you run the Docker Swarm init, Docker Swarm join, and suddenly you've got your cluster. So if I go back to my manager machine here, clear the screen down, we've now got everything that we need to join. And if I go and look at my nodes again, so when you're in swarm mode, you get a few new commands available to you. So it's the same Docker command line, it's talking to the same Docker engine, but because I'm in swarm mode, I've got the Docker node command, so I can list out all the nodes, and I can see what I've got running here. So I've got my manager node, and it tells you which versions of Docker they're all running, what status they're in, whether they're available or whether they're not accessible among the swarm, and whether they're active or not, which means whether they're ready to do work, whether they can have containers scheduled on them. And the swarm knows an awful lot about those nodes. So just like we've seen the Docker inspect commands for containers and networks and all that sort of stuff, where you get this big chunk of JSON out, I can run that on my node as well. It tells me, among other things, can you see that with my head there? Yes. It tells me the address of the network address of the node. And if I scroll right up here, I've got all the Docker plugins. So Docker supports lots of different plugins for things like where logs get sent to, which type of volumes you can use. In swarm mode, you get a few more available. And then it tells me the operating system and architecture. So this is an Intel 64-bit machine, and it's running Linux. And there are a few other things here. So the Docker knows that this is a worker, and the availability is currently active. And you can apply labels. So those key value pairs that you can apply to all sorts of objects within the Docker world and in the Kubernetes world, they're really useful for management, and you can use them to direct your container workloads to certain nodes or keep them away from other nodes, just by applying your own labels to kind of specify where you want things to be. Okay, so Docker knows a bunch of stuff about all of the nodes. And then this is it. My cluster's up and running now. So if I want to run containers in the cluster, it's a slightly different abstraction. So in an ordinary Docker machine, I would do Docker run to start my container, or I would do Docker compose up to take my application model and start that in containers. There's a different abstraction in Swarm mode, and Swarm mode takes that same concept of the service that you've got in your Docker Compose definition. But in Docker Compose, that doesn't really map to anything. You define your services, and when you do Docker Compose up, you just get containers. Whereas in Docker Swarm mode, when you create a service, it is a thing. It's actually implemented by containers that run somewhere on the cluster, but you create the service and you work with the service. And it's really simple to get up and running with the service. So what I'll do is get some more space for my docs. So you run a Docker service create command. And again, this is the additional functionality you get available to you when you're running in Swarm mode. So I get these Docker service commands, I get the Docker Swarm commands, the Docker node commands. I can do a Docker service create, and I give it the name of the service that I want to run. I can publish ports just like I do with a Docker run command. So this is going to take port 8080 on the cluster and listen for any incoming traffic. So all the servers will listen on port 8080, and any traffic that comes in will get intercepted and sent to the container on port 80. And the image I'm running is one from my Docker book, my Learn Docker in a Month of Lunches book. It's just Apache, really basic web server, really lightweight to get up and running. So I'm going to run my Docker service here, my Docker service create. And naturally, this will run kind of instantly when I ran through it in when I was checking through. But this is all it's okay now. So what I get is the output. I get the ID for the service. Then I get this thing where it's verifying and waiting to make sure the tasks are stable. So there's some different terminology in the orchestration world, and Docker Swarm is no exception. It calls the service is the thing that describes your application, and then the containers are called tasks. And so when you're working with your processes that are running your service, they're actually containers that are running somewhere on the cluster, but Docker refers to them as tasks, which is why you see this waiting to verify that the tasks are stable. Okay, so that looks all good. So now if I do a Docker service PS, that will show me all the containers that are running my service. And the information I get here is I get kind of random ID. It tells me the name of this task. So there's just an index at the end there. So if I was running multiple containers from my application, I would see multiple of these. It tells me which node they're running on. So this one happens to be running on the manager node, but I've got 3 nodes, so it could have been on any one of them. There's a scheduling algorithm inside the orchestrator which works out which servers have got free capacity and all that sort of stuff, and it allocates the container to the best one. And the container's running, and it's been running for 35 seconds. So that all looks pretty good. If I go and clear this down, because I've published the port, Docker Swarm mode has this concept of an Ingress network. So like I said, every machine is listening on port 8080. Even though only one machine is actually running a container, I can send traffic into any machine, and Docker will receive that traffic and route it to the machine that's running the container, all kind of transparently. So if I go and get the IP address of my worker, so that's my worker 1, if I get the IP address of worker 2 as well, what I should be able to do is browse to port 8080 on either of those machines. So let's go over to Firefox. This is my worker 1 node. If I browse to 8080, there's my response from Apache. So this is just the default page with Apache. So it says it works, which is great. And if I go and get the IP address for my worker 2 node, so these are both in the same cluster, but they're completely separate machines, and neither of them are running my container. If I browse to that one, then I get the same response back. So this Docker Swarm calls this the Ingress network, and it's super easy to use because there's no real configuration. You just publish a port, and Docker takes care of the rest. So any server can receive that incoming request, and if it's not running a container that's hosting that service that it's listening for, then it will forward it to another server, and it all happens kind of internally within the cluster. And it works the other way around as well. So if you over provision your service, so that you're running multiple containers per server, then when an incoming request comes into a server, it load balances across the containers where it's running. So I can update my service here. So I can do a Docker service update. So normally, of course, you'd have all this inside your YAML file, inside your Docker Compose file. I've got a bunch of those to show you as the episode rolls on, but you can work with services directly. So just to show you, if you need to kind of manually deploy and edit your services, you can do that too. So Docker service update is going to change my existing service. And what I'm asking it to do is to change the number of replicas. So that's not helping because that's just an IP address. It's going to change the number of replicas from 1, which is the default, to 10. So I'm going to spin up 9 new containers all across the cluster. So when I run this here, I'm going to see all these things that are starting up. So the orchestrator, the machine that I'm talking to, is the manager, and it's telling the other nodes to start these containers, and it's waiting for them all to come back and say the containers are all up and running. So everything looks good now. So now if I do my Docker service PS, I should see lots of containers. So you see they've all got these suffix for the index of where they're running. There's a variety of different machines. So the manager, the worker, worker 2, they're all running these containers. It's all the same container image. It's on Docker Hub, so you can run these commands yourself and you'll get the same output if you want to run a website that says it works. And everything's kind of up and running in the same way that you expect. If I clear this down now and look at the IP address for the manager, just to prove that any machine can get those requests, if I browse to this machine instead, so I'll go back to Firefox and we're on port 8080. And so I still get that response, but now it could be going to any one of those containers. So it gets kind of load balanced between the servers and then within the servers, so the containers that are on the servers. And that's all taken care of for you just with that publish argument to your service, which is the same as the publish option that you put inside your Docker Compose file. So this is why I say that Docker Swarm is super easy to get up and running with. Okay, let me just go back here. I'm going to go and browse a few more times and refresh a few times and just make sure they're all working from all those different servers. And then the other thing is that your service is really the thing that you interact with. That's the management side. That's what you're going to operate that's what you're going to use your kind of management tools for. So I've got all these containers now that are running across all of my servers. In a production environment, I would have a logging subsystem set up. So I'd have, Elasticsearch and FluentD and Kibana set up. So collect all the container logs and give me this nice centralized way of viewing them all. But I haven't got that because I've just created my cluster. So if I want to see the logs, I can do a Docker service logs command, and I don't have to connect to each of the individual servers and look at the service logs. So I can do, so I should point that out, when you're running in Swarm mode, you can still access the containers on the server. So you can connect to a particular server, do a Docker PS, do a Docker exec to connect into that server, do anything else that you need to do. But normally you won't do that, especially think of a production environment where I've got dozens or hundreds of servers, and you can easily manage a cluster with 100 nodes just from 3 manager nodes. Then you're not going to want to connect to each individual server and see what's happening. So you're going to manage it at a higher level at the service level. So if I look at the Docker service logs for my Apache, obviously there's a whole bunch of stuff in here. This is why you really want a centralized logging system. And I can see that each line comes from, let me find a good example here. There's some weird stuff that comes from Apache. So I don't know what this is, some sort of Apache error message. But as part of the error message, this is after the pipe sign, there's all the content from the actual log entry. And then before the pipe sign, it tells me the index of the task, so the container ID, and then the machine that it's running on. So I can see that this is running on worker 2, and there's the output that's come through there. And I can see here, these are the actual responses that are coming through. My head in the way? No, my head's okay there. So I can see a worker 2, there's a get request. Those all came to worker 2. If I wait long enough and refresh and all that sort of stuff, I would see it being distributed across all the nodes on all the different workers. So we can see here, there's a bunch of stuff coming through from Apache 10, Apache 4, and they're all coming from different parts of the containers that are running somewhere across the cluster. It doesn't really matter where they're running. That's not the level that I need to manage. That's what the orchestrator does for me. If I'm done with this, I can just do a Docker service RM. That's going to remove all of the containers. And it will just, again, the manager will just tell all the worker nodes to get rid of their containers. And if I do a Docker PS, so I'm on the manager node here, there's nothing running. So the manager, the bits of the orchestrator, the scheduling component, and all the other bits that actually provide your orchestrator, like the API server, all that sort of stuff, they don't run in containers, which they do on Kubernetes. So when we do this next week for the Kubernetes episode, you'll see there's a whole bunch of containers running that provide the core parts of Kubernetes. But Docker Swarm doesn't work like that. Everything is happening inside the Docker engine, so there's no kind of multiple components, distributed components for the orchestration unit itself. So you don't have to manage all those other components. It's just Docker. As long as Docker's up and running, then everything's up and running. So a question from Paul. So I've got my chat sorted out this week. So I've got my restreaming application with the chat thing. So Paul's saying, when you spin up multiple replicas, are they all on the same port? So yes. So and there's no clash. Like if you did Docker run, if you try to do a Docker run with 2 different containers on the same port, there would be a clash. Only one thing can listen on one particular port. So you will publish the port, and that's across every node in the cluster. So all my nodes are listening on port 8080, but they're only directing traffic to that one service, that one Apache service, wherever the containers might be. If you need to run different services, then you'll publish different ports. Or what you would actually do in production, you'd have one thing listening on your port 80 and port 443, which would be a reverse proxy. So all the traffic would come into that, and it would fetch from your other containers. But yeah, so when you're publishing your service, any server can receive a request. They're all listening on the same port, but different services need to use different ports. Okay, so now here's how we do things for real. So we will really use a Docker Compose manifest. Let's close my terminal down, get some more space. So is that going to open? Yes. Okay. So with Docker Swarm mode, the Docker Compose syntax is perfectly valid. So it doesn't matter how many servers are in your cluster, or how many worker nodes you've got, or whether some of them are Windows and some of them are Linux, which you can do exactly the same stuff that I've done. Incidentally, if you're trying to run a multi-architecture application, then you can go onto a Windows machine, install Docker, and do a Docker Swarm join in exactly the same way. You can even have an entire Windows swarm with Windows managers too. But I've done the Windows topics before, so I won't go into that today. When you're running your applications, you can use standard Docker Compose. So this is a typical Docker Compose format. It's the same boring to-do application that we've seen. So there's a to-do database that's running Postgres. It connects to this to-do network. There's my to-do web application, which is a .NET Core application. There's the port that I want to publish. Here's some environment settings with some stuff in there that shouldn't be in there, like the database connection password. I can say that it depends on the database, connects to the same network, and then I've got that network definition down here without any options, so it'll just get created with the default network. So I can use this Docker Compose command with Docker Compose up, or I can deploy it to Docker Swarm. Some things don't make any sense when you're running in Swarm mode, like the depends on flag. So in Docker Compose, it's a single server. It'll make sure any dependencies get started in the right order. So the database container gets started. Docker Compose waits for it to be up and running before it starts the web container. But in Orchestrator, that doesn't make any sense for quite a few reasons. You want your orchestrator to be able to spin up your containers and spread them around as quickly as possible. You don't want to have to model these kind of dependency graphs, because then things get very confusing. Like if I've specified 50 API servers and 20 web containers, then like do the web containers have to wait for all 50 API containers to start, and things get kind of out of hand. So you need to remove that dependency graph, and your application containers need to be able to deal with that. And so that's one of the other things that I cover in the books. Okay, so that depends on flag won't mean anything. So Docker Swarm just ignores it and it will start the containers all at the same time. Okay, but it's a standard Docker Compose format. Let's clear this down. I need to go to the right place. Make sure I'm in there. No, I'm not in there. Okay, so I'm going to browse to the source code. So the code for today's lesson is all in. It's mounted inside the Vagrant virtual machine. So the Vagrant machine can see the stuff that you can get from GitHub. So I'm going to do a Docker stack deploy. So when you're working with Docker Swarm mode, if you want to deploy an application from a compose file, you do Docker stack deploy, and it creates this thing called a stack, which is just a grouping mechanism for containers and networks and whatever else you define there. So that's one thing that Docker Swarm does that the other orchestrators don't do. So Kubernetes, there's no real way to kind of group things together to say they're all part of the same application. Whereas with Docker Swarm, it tries to give you this abstraction across multiple services to say these things form one application that I'm calling a stack. So I do a Docker stack deploy. I give it the path to my compose file, and I give it a name. I'm calling it to do one. And it's going to create all those things, similar sort of output to Docker Compose. So it creates my network, creates my web, and you can see that the dependency just gets ignored because the web one comes first and then the database one comes. So when you're running in production, when you're running in an orchestrator, if you do have dependencies, you need to take care of that inside the container. You don't want to model that outside of for your orchestrator to have to deal with. So you need to be able to say that if my dependency isn't there, then the container fails gracefully, and then it gets restarted by the orchestrator, or however it works for your application. Okay, so that's all been created, and that Docker network that I specified in the compose file, I didn't have any details around there. It was just the default network. If I ran that in Docker desktop on Windows, I would get a NAT network because that's the default driver. If I ran it on Docker on Linux, I would get the bridge network, which is the default driver. If I run it in Swarm mode, then I get way up here, I get the overlay driver, and the overlay driver is the kind of internal part of Docker Swarm managing traffic between containers. So we've seen the Ingress part where external traffic comes into any server and it gets routed to your container. This is within the cluster. So if I want to talk container to container, I have to create this Docker network, which is an overlay network, and that spans all of the servers. And then everything works in the same way that it normally would. So within an overlay network, containers can reach each other by using the DNS name for the service, just like they would on a single Docker machine or with Docker Compose. And because I'm in Swarm mode, that is the default type of network that's created for me. So I've got everything up and running, so that should all look good. Stacks are first class citizens, so I can do a Docker stack list, and I can see that I've got 2 services in my stack. If I do Docker stack services, it'll tell me what they are. And I can see here I've got my service name is kind of prefixed with the stack name. So to do one, to do DB, it's replicated, which means it's running across the cluster generally. The alternative is to have a global service where you get one container on each server. If you some situations you need to be able to have that. I've got one replica requested and one is up and running. And then for my web application, as well as all the usual stuff like the image name, I can see that I've got my published port there. So port 8010 on the cluster is going to route into port 80 on my container. Okay, and if I do, if I clear this down, if I do and look at the individual containers, I can do a Docker stacked PS, and this is going to give me a way to drill down into everything that's running my components. So I got my database container that happens to be running on the worker node, on worker one, and my web container happens to be running on the manager. Okay, so I can browse to any of my servers on port 8010. So if I go into 8010 this time, then we'll see the less than fabulous to do application, which I've been staring at for the last couple of years. So, you don't get any apologies from me if you're fed up with it too. And it just works the same way. So I can go and add a new item. I can say whatever I normally put, finish ECS-O2, and that gets stored in my Postgres database. They're running in containers on separate servers, but both those containers are connected to the same overlay network, so they can reach each other in the same way as usual. Yes, so Bryce is answering Paul's question. Thank you, Bryce. That's exactly right. Okay, cool. So that's up and running as expected. So on port, that's I'm using the Ingress network. So any machine can receive a request on that port, and it gets directed into the container. And then within my web container, it's reaching my database container just using the DNS name, and it happens to be on a different server. It doesn't make any difference. It's all transparent to the container and to the application. And again, if I was running a multi-architecture solution here, and I happen to be using a SQL Server database in a Windows container, exactly the same deal. Inside my application model, I can say this component needs to run on Windows, but then the containers can just connect to each other with their DNS names. Okay, and there's some other things that you can put into your Docker Compose specification. So you can take a really basic Docker Compose spec and run that as a stack, as I've just done. But there are additional things that you want to be able to capture in your application model when you're looking at running in production. I'm not going to cover them all here because we've only got kind of 15 minutes left, but I'll cover some of the basics so you get a feel for how that works. In the Docker Compose specification, there are parts of it that only apply when you're running in Swarm mode, and there are parts of it that only apply in Compose mode. So that depends on flag. Docker Compose will honor that, and Docker Swarm mode completely ignores it. And there's a flip side, there's a whole bunch of stuff that you can put in your Compose specification that Docker Swarm makes use of, but Docker Compose completely ignores. And the other thing is, of course, which I talked about in the last episode, is that your orchestrator is not just for running containers. You can manage other types of objects in there. So we've seen Docker networks, they're managed by the orchestrator, but then you can also create configuration objects and store those inside the cluster. And that's really important because that's what you're going to do as you move towards production. When you run in production, you're going to have your containers are using exactly the same image that you've promoted through all of your test environments. So your CI process will generate this Docker image. Maybe you've got security scanning and all that good stuff in there, so you're sure your image is safe and healthy to run. And then you'll run that through your different environments with automated tests and manual tests and whatever process you have. But you're going to take the same image and move it through your environments. It's a real anti-pattern to have a dev flavored image and a test flavored image and a system test flavored image because they're not the same set of binaries. It's hard to track down and have an audit trail to say what we're deploying in production is exactly the same set of things that we packaged up and used in the other environments. Whereas if you make sure you use that same image everywhere, you can have that audit trail. And then you need to apply your configuration from the platform. So when the container runs, it picks up the config files or the environment variables and it changes its behavior, but it's the same image everywhere. So kind of core pattern that you need to have when you're working with containers. And Docker Swarm lets you do that. All the orchestrators let you kind of save configuration in the platform themselves. So I can take some config files like this. This is the configuration file for my web application. I'm telling it to use the Postgres database. I'm overriding the logging level, so I'll see some more logs in there. All the usual things you would have in a config file. And I've also got another file for my secrets. So Docker Swarm and Kubernetes, they both have this approach of letting you separate sensitive data from kind of public data. So I can store things in configuration files, in config objects in Docker Swarm, which people can read, but things that I'm saving in secrets. Inside here, I've got my highly difficult to guess Postgres password, which is just Postgres. That lives inside my secret. I can surface it inside my container, but I don't necessarily want other people who have access to my cluster to be able to read the secret. So Docker Swarm and Kubernetes give you different ways to manage sensitive and non-sensitive configuration data. So I can take these files here. those are the formats that my application is expecting to see. When I store them in the cluster, they get stored as Docker Swarm objects. So again, config objects, they are first class objects. So I can do a Docker config create. I give it a name. I'm calling it to do web config, and then the path to that JSON file. So this happens to be JSON. It could be XML. It could be a Java properties file. It could be TOML. It could be whatever your application uses. And when it's stored inside the cluster, again, they are real objects. So I can do a Docker config list. I can see that it's there. It's just been created. And if I want to look at the contents of it, I can do a Docker config inspect. And with this pretty flag, it gives me the actual data that's in there. So I've got some metadata here, the ID and the name and all that sort of stuff. And then down below, I've got the raw data inside that config object, which is my JSON. So I can see that. I can work with config objects, see what's being deployed. I can see what's being used in my application. But for my secret, it's a slightly different approach. It's the same UX. I still, I do a Docker secret create. So here I'm going to do my Docker secret create, call it to do web secrets, and I'm passing it to my other file, which has my database connection string with the sensitive password in there. Same thing, I can do a Docker secret list to see what all my secrets are, and it's in there, it's just been created. If I do a Docker secret inspect and get my head out of the way, then I can see the metadata, but I can't see the actual content. So with Docker Swarm, when you create a secret, it gets encrypted in the Swarm database. It gets encrypted in transit. So when I start a container on a node over here, Docker encrypts the secret on the way to the node, and it only gets decrypted inside the container file system. So only nodes that need that secret get access to it. It's encrypted all the way along, and it's only unencrypted inside the container. And even then, it uses like a RAM drive, a memory map, so that you can't just kind of like pull the disk out of your node and see the secret. So it's all kind of nicely encrypted all the way through. Okay, and now if I close my terminal down and have a look at my extended Docker Compose file. So this is how I would extend my application model to include some of these more kind of production-y things. And what I've got here, I haven't changed my to-do database at all, so I'm not doing anything much with that yet. But for my web application, I'm adding in these configuration sources that come from the platform. So I'm using that same container image that I've used before. This time I'm using a different port because I'm going to run this alongside my other stack. So I can't use 8010 or 8080 because they're already in use. And then I'm mapping in my configuration. So if I scroll down here so we can see the whole thing. So my configs, I can list those in my Docker Compose file, and depending on which version of Compose you're using, they get ignored. If you're using an older version of Compose, they just get ignored when you do Docker Compose up. They only apply when you're using Swarm mode. So I'm saying that the source of my config is something called to do web config, and the target is the path where it gets materialized inside the application container. So when my container runs, it'll have a file at /app/config/config.json, and the contents of it will be the data that's in the config object from the Swarm. And then I also have to reference that down here. So just like I've got my networks defined separately, I've got my configs defined separately. I'm just saying it's external. So it needs to already exist. If I try and deploy this stack and the config doesn't exist, the config object's not there in the Swarm, then it will fail. So, it's just a kind of nice way of making sure that already exists. And then the same thing for my secrets. Same user experience, but a different stanza inside my Compose definition. And again, I'm saying here's my source, it's to do web secrets. I'm going to surface that inside the same folder, app config, and this will be secrets.json. And then also I've got my secret defined as being external, so it needs to exist. So this is the modeling part of it. So inside my cluster, I can store those objects. Inside my model, I can surface them inside the container file system. But then my application needs to know what to do with them. So this isn't completely for free. Your application inside the container needs to know that to look in those particular locations. So it's a combination of work that the dev side that happens when you're packaging your application. So it looks in certain places for configuration, and then your app platform needs to be able to merge them together into one set of settings. And then in your actual modeling, in your runtime on the ops side, you need to know where those things get surfaced. So it's not, you can't just do this on the container side. You need to do some work in your application or in your container image to make that config available. Okay, so that's all how we define that. And if I clear this down again, we'll get this running. So my new Docker stack file, you can call it whatever you want. So I've just happened to call it Docker stack this time. I'm deploying it to a new stack called to do 2. So my existing application is still running. This is a new stack, happens to be running exactly the same stuff, but I've split out the configuration definition from the application definition. So I might have separate teams who own the config in my production environment, and they would own that workflow of doing, the config create. and managing the actual configuration files that get used in each environment and deploying them to the cluster, they would do that part first. And then maybe, the product team, or if we're doing something more DevOpsy, the other team would have access to deploy the application, and you can model the fact that my app needs that config file, but let somebody else manage the actual config. Okay, if I look at the things that are running in this stack, so as expected, everything's up and running, manager and worker too. So again, it doesn't really matter where your containers are running. If you just want to get a high level view of your services, it'll tell you that everything's up and running, and that's kind of all you need to know. Okay, so, I should have done that first. So we're in Docker stack PS. So I want to go and look at the machine that's running my web component. So here, that's running on the manager, and that's helpful. So I can go, I'm already on my manager machine. So I can do a Docker PS here, and I will see my containers are up and running. So there's my to-do list. There's the most recent one that's been up for about a minute, and that's the ID 314. So like I said, when you're running in swarm mode, you're still just running containers. So if you look at each individual machine, there's just a bunch of containers that are running. But when you look at when you connect to the manager node, then you get that whole view across all of the services and the stacks. But if I need to connect to a machine to connect to a container, I can do that. So if I clear this down, if I do now a Docker exec, so let me paste that container ID. So Docker exec IT. So I'm going to connect to that container. I'm going to run a command. I'm not going to do that. I'm going to do this. So let's copy that here, and I'm just going to run a terminal inside there. So I'm going to run my shell session, and then if I'm in, so this is my web container where I've done that configuration in my app model to say load those files from the config in the cluster, from the secret in the cluster, and surface them in the container file system. So if I look at that directory, and that directory is empty in the container image. There's nothing there from the image. So in a container without any volume mounts, then I wouldn't see anything in there. But there I can see my config and my secrets file. If I look at the contents of the config file, then as expected, that's that same lump of JSON that I saw in the JSON file and that I can see from the cluster when I inspect the config object. But if I look at the secrets, now I get the unencrypted plain text. So this is being mounted somewhere in the container file system, and there's a symbolic link that will take me to the real place. But here's the actual thing that's unencrypted. This is the only place you'll see it unencrypted once you've created that secret. So admins can't read the contents of the secret. The only way you can get to it is by mounting it inside a container and having a look inside the container file system. Okay, so that's how those things look. Now, there's a few other things you would need for production, so I'm not going to go to the full production deployment here, but I have got multiple servers. It's really great for like a test environment. You can spin this up really easily. If I look at Docker Stack 2, and I want to see how my application runs when I'm doing things in a more production-y way. So just a couple of things I've pointed out here. In the text, there's some other stuff here. So I would ordinarily have health checks so that my container orchestrator knows that if there's a problem with one of my containers, it will restart it. It can tell if the application isn't healthy. It can restart the container or replace the container. I would have configuration for how Docker does its updates and rollbacks. So Docker Swarm and Kubernetes, they do this kind of staged update where they'll create some new containers and then take some of the old containers away and distribute the traffic among all the healthy ones, all that sort of stuff. And you can tweak all of that. And things like, making sure your user IDs, that all your containers aren't running as root, all that stuff would live in that application model in your kind of gradually increasing Docker Compose YAML file. But in this example, I've just got a couple of things in here. So this deployment stanza, that's the thing that gets ignored by Docker Compose. So the deployment section only applies when you're running in swarm mode. For my database here, I've explicitly said that there's only one replica, but that's the default. So, I don't necessarily need to have that unless you're really keen on documenting defaults in your application as well. But for that replica, I'm specifying the resources. So I'm saying that there's a limit here of what my container can see. So ordinarily, when you run a container, it kind of sees all of the compute resources that are available to the machine that's running Docker. So if I've got 8 CPU cores and 32 gig of RAM, that's what the container sees, and it can try and use as much of that as it wants to. If you apply these limits, so what I'm saying here is I'm limiting this container, my database container, to half a CPU core and 500 meg of RAM. That's all it will see. So this is really important when you get to production because it's a nice little safeguard from people trying to max out your application, which then maxes out your container host. If you don't have any of these limits on here and your application goes crazy, then it can use up all the RAM and all the CPU on the machine and starve all of your other applications. So having these kind of resource limits is kind of a must before you get to production. So that's just for my database, and like you have to work out for yourself what those reasonable limits are. So there's some kind of monitoring work to do in your production environment to see what you can get away with and trim that down so it's a sensible maximum. And then for my web application, I've got that sort of stuff too. So I've still got my configs and my secrets. So I'm mapping in my configuration from the environment, from the platform where I'm running. And then in my deployment section here, I'm running with 5 replicas. So this will give me high availability and scale. So my web application, Docker will distribute all the traffic that comes in across these containers. If one of my servers goes down, then the containers will get replaced on different servers to make sure that Docker Swarm will make sure that my service level of 5 is always available. And then I've got my resources in here too. So I'm limiting this to half a CPU and 100 meg of RAM. It's a .NET Core application running on Linux. It's pretty lean, so I can put that down to quite a small level and limit it quite extensively. So there's other stuff that I would need to put in here for production, but this is giving you a feel of how you kind of evolve your application model from here's my really simple Docker Compose spec that I've run locally, and then I'm adding in this other stuff. I'm working out how many replicas I need. I'm putting in those limits. I'm moving the configuration out of the container image and out of environment variables and using config objects and secrets that are much easier to manage and much clearer to express. And then I'm putting in these resource limits. I'll put in my health checks, all that other sort of stuff. Okay, so I've still got my Docker Compose here. So that's clear. Oh, I'm already clear. So I'm going to deploy my new version. So I'm going to call it the same thing. So when you update your application in an orchestrator, you typically just run the same command again, maybe with a new set of files or a new YAML file. So I'm saying docker stack deploy with my new file, which is docker stack 2, but it's the same stack. It's the to-do 2 application stack. So instead of deploying some new stuff, it's going to update the existing stuff. And what we can see here is that all my service definitions have changed. So changing the compute resources that your application container can see, that's a change of the container environment. So that means it's going to be a new container. So my database application, I've changed the CPU available, so it can be a completely new container. And the same with my web application, it's updating the service. It's going to spin up some new replicas for me because I'm now moved from 1, which is the default, to 5, which is what was specified in my YAML file. So if I look at this now, when you run your Docker stack PS and your Docker service PS, the output gets kind of big because it shows you all the previous history of your containers as well. So what I've got here, if I look at my my to-do web application here. So here's to-do web.1 that was shut down. So that was originally running on the manager, and my new to-do web.1, oh, that's another shutdown. Well, that's the database that's been shut down that was running on worker 2, and the new to-do web.1 happens to be running on worker 2, and so does the database. So it doesn't really matter where these things run. They're all going to connect across that overlay network. They're all going to be listed, all the web application containers are all going to be available using that Ingress mesh to get traffic into my application. Okay, so we didn't really see it, but this would have happened as a staged rollout because I just had one container running previously. Then Docker Swarm will stop that container and start the replacement. If I had multiple, then it would stop one at a time and bring one up at a time. And again, you can configure all that to say, rather than stop first, do a start first, stop 10 at a time and start 10 new ones, or whatever you need to do. It's all kind of very, very highly configurable, but your application model quickly gets pretty complicated when you're adding in all that stuff. Okay, so let's go to 8020 this time, which is my new application. And what I should see here, everything should hopefully be up and running. Yeah, so that's all good. So if I browse to this, then this is hitting different web containers that are running on different servers. It doesn't make any difference. There's no data in there, but I should be able to add something new. So if I do my finish ECS-O2 again, that should get saved. And again, it doesn't matter that this web container is talking to this database container on different nodes. That's the whole point of the orchestrator. It abstracts all that stuff for you. So it abstracts the networking layer in terms of ingress into the containers and communication between the containers. It abstracts the compute layer with those services that run across all the nodes. And it also abstracts other things too. So like the storage layer, which we're not going to get into today, but you can have storage attached to your containers that is living accessible somewhere from the cluster. Okay, and the last thing I'm going to show you is how you can manage those nodes. So again, when you're looking at Docker Swarm, if you're thinking, Docker Swarm, certainly doesn't have the uptake of Kubernetes. You can't run a managed Docker Swarm in any of the clouds like you can with Kubernetes. There is a supported product that you can buy. So Docker Enterprise, which was originally created at Docker and then got sold off to a firm called Mirantis. You can, if you're running in-house or if you're running in a cloud and you want a managed Docker Swarm experience, you can pay for that, but it's all part of the open source engine, so you can use it yourself. It's super simple to get up and running with. And if you want to see, like, what does the workflow look like when I'm kind of past the day one deployment, and I'm looking at further on down the line when I need to do an operating system update on my nodes, or update the Docker engine, or take a server offline so I can put some more RAM in it. You can kind of work through all those scenarios with very little investment, just by spinning up a Docker Swarm, doing Docker Swarm init and Docker Swarm join with whatever hardware or virtual machines you have available. So let's just see what I've got running for my to-do web application here. So I've got all these web containers that are running across different nodes. So every node is running at least one of them. So I'm going to take, so worker 1 here is running 2. Yeah, it's running 3 and 5. So it's running 2 containers for this application. So if I want to take worker 1 out of my cluster because I need to put some more memory in the thing, or update the version of Windows or Linux that it's running, I can set the availability to drain. And what drain mode means is I'm going to get rid of all the containers that I'm currently running. So those 2 web application containers, they're going to be shut down, and the node won't be scheduled for any more work. So if I deploy any new applications, worker 1 won't be part of the pool that gets selected from. So I won't run any new applications. So it's still part of the cluster, but it won't do any work. So I can do things to it and then bring it back online again. So if I run this Docker node update, I'm setting the availability to drain for that worker. And now if I look at my nodes, what I can see is that Docker knows about these things. So it knows that worker 1 is ready, which means it's still communicating. It's sending heartbeats to the manager. It's up and running. It's still part of the swarm, but it's in drain mode, which means it's not going to run any containers. And of course, Docker knows that. And then the orchestrator will take action to recover the fact that that worker node was running 2 containers and it's not running them anymore. So if I clear this down and have a look at the containers on that node, so Docker node PS shows you the tasks, the containers running on the worker node, and they're all shut down. So I have my web application, I have one of my database containers, they've all been shut down, so there's nothing running on there. And again, if I clear this, but if I clear this by actually typing clear, if I look at the service, my web application service, then I can see they're all running. I can see that I've got 1, 2, 3, 4, 5. They're all running, but they're not running on worker 1. So they've been rescheduled. So worker 3, the Web 3 container was originally on worker 1, and that's been replaced now with one that's on the manager node, and the same with worker 5. So the original one that was on worker 1 is shut down, and it's been replaced with one on the manager node. So this is the high availability that you get from your orchestration platform. It's looking at the requested service level for my web component, which was 5 replicas. Some of them went down because I took a server took a node out of the pool of workers. And so it started replacements elsewhere. And the same thing would happen if my containers were failing their health checks, or if the server went offline because of a power outage. Then I would still get that kind of availability. So the orchestrator will do all it can to give me the service level that I've requested. Okay, and then the last thing I'm going to show you is that if I want to bring that back online, so I've put some more RAM in there, so I can change the availability to active again for that worker. Still part of the swarm, so I'm still managing it with a connection to my Docker manager in my cluster. So I'm going to do a Docker node update. And now if I look at the containers that are running, we'll see there aren't any. So this is an important thing to realize, when you add new capacity to your cluster, and this kind of works in the same way with all orchestration components, you don't automatically make use of that new capacity. So I've got another server that's come into my cluster, a node that's available for work, but it doesn't get any work scheduled because everything that I want scheduled is already running on the other servers. So if I had work queued that couldn't be run because there wasn't enough capacity, then the new machine would pick up that work. But any work that's already allocated, it won't be shut down and moved, because that's potentially a loss of service if Docker did that. So it's going to leave everything running on my previous machine. So my new server doesn't have any containers that are up and running, even though it's come back in and joined the cluster again. If I look at the nodes here, then I can see that it is active. So worker 1 and worker 2 are both active. So Paul says, in production, you need a load balancer or something in front of the nodes. Absolutely. Yeah. So in a production environment, you're going to have, and it's the same with Kubernetes. And if you do this in one of the cloud environments, it will create a load balancer across all of your server nodes. So you'll have a single IP address, which is what you map to your CNAMEs and your DNS server. Any requests come into there, and then that goes into your reverse proxy typically, and that shares the container load around. And anything that's not part of the cluster. So if a server is not available, if a node is not available, or if it's in drain mode, then it won't get those requests either. Okay, so now that machine is up and running. And if I want to rebalance the service and bring some containers to my node that's available for work again, then I can just forcibly update the service without changing the definition. So this is a big difference from Docker Compose. Remember in the Compose section when I was talking about that in episode ECS-O2, you have to have your Docker Compose file with you if you want to make any changes. So you can't just, there is no database that stores the application model. It's only in your YAML file. But when you move to an orchestration component, that is all stored inside the database. So I don't need to always bring my YAML file with me. So if I want to forcibly, effectively restart the service, restart the containers, then I can do a Docker service update. I'm not changing any of the parameters, but I'm just doing that force flag. So what it will do then is it will reschedule containers. And because I now have worker 1 and worker 2 and the manager available, then they'll get spread out across the whole cluster. And that's how you do your rebalancing. It's kind of manual way of saying, I've messed around with the capacity of my cluster. I've taken some nodes out and brought some back in. Everything's still running, but maybe it's crammed on a couple of servers. I want to spread it out again. This is kind of how you do that. So it'll go through and start all those containers for me. I'll make sure that everything's up and running, so it all looks good. And now if I do this Docker service PS, I can put a filter on here to just show me the ones that are running, because I don't want to see all the millions of stopped containers. And if I look here, the ones that are running, everything's up and running here, so that looks good. And they're spread across all the nodes again. So a couple on the manager, a couple on worker 1, and 1 on worker 2. So it's a kind of manual way of saying that I've got, you're not using the full cluster, the full capacity of my cluster, and so I want you to do that for me. Okay, so if you're kind of following on yourself, if you are doing these, running through these examples, then the way you manage this stuff, the way you manage the teardown, you can remove the stack. So you can do a Docker stack RM and get rid of everything that's up and running. And then if you want to leave the swarm, if you want nodes to exit the swarm, you do a Docker swarm leave with the force flag, with the F flag. And then then your worker nodes will leave the swarm, and then in the manager, if you run that on the manager node, that gets rid of the swarm altogether. So when I'm done with this presentation, I can exit all the swarm, which brings me back down to an ordinary set of Docker engines that are not connected. So I just have 3 Docker engines that can run containers independently, but they're not part of an orchestration unit. And then, when I'm done, I'll do vagrant destroy, and that'll get rid of all my virtual machines as well. Okay, so we're a bit over time today. So thanks for your questions. I'm glad this has kind of been helpful for you, I hope. Next, we're going to do the same sort of thing with Kubernetes. So we'll see how far we get with the time, but I'll try and replicate everything that I've done here, but with Kubernetes instead. So I'll have some virtual machines ready to go. I'll show you how you initialize your cluster with Kubernetes, how you model your applications. There's a whole lot more to Kubernetes than there is with Docker Swarm. There's a lot more abstractions that you have to kind of layer together. But I'll show you what the YAML looks like when you're building these things in a kind of production-ready format. So rather than just have a really simple YAML file that leaves you guessing what you do next, I'll show you all the kind of the additional details to deal with those kind of production concerns. So you see what your Kubernetes manifest look like, and you see what Kubernetes gives you, which Docker Swarm doesn't do. So Docker Swarm doesn't do everything that Kubernetes does. So typically people are looking at Kubernetes for their production deployment. But if you're completely new to the whole orchestration thing, then Swarm is a good way to get started. As you've seen today, it's really simple to get up and running. You're using the Docker Compose format, so it's nice and easy. And when we look at Kubernetes next week, you'll see there's a lot more to it, and there's a lot more to learn. So thanks for joining. Thanks, Mike. I hope that was useful, and I'll see you again next week.